All right, so I'm going to be going through page 11 of the honors packet. These are some application word problems related to solving quadratics using square roots. So starting with the first problem, we have a patio is composed of two parts, a square and a rectangle. The rectangular part has an area of 120 square feet. The total area is 376 square feet. We have to one, write an equation to find the side length of the square part of the patio, and B, explain whether all solutions are viable. So looking at this, we're trying to find one, we're trying to find a square part and a rectangle part. Right, the patio is composed of two parts, so we want to identify each of those parts. I'm looking at this and I'm saying if I cut it right here, this looks like a square, and this looks like a rectangle. All right. What else do we know? The area of the rectangular part has an area of 120 square feet. So the rectangle over here, we're going to say A is equal to 120 square feet. And then the final thing we know, the total area is 376 square feet. So that means that the area of this square plus, so the area of this square plus 120 square feet is going to give us the total of 376 square feet. Now we need to write an equation to find the side length of the square part of the patio. So what I didn't write here was the area of the square. And that's because we're trying to find the side length of the square part of the patio. So we want to come up with an equation for the area of the square part as a function of the side length. So we call this the side length S. Then you might remember that the area is equal to the side length squared. Okay, that's the area of a square, it's just the side length squared. So if we know that the side length is, um, if we know that the area of the square is the side length squared, then we know that the area of the square plus the area of the rectangle gives us 376. We can write this equation. S squared, the area of the square, plus 120, the area of the rectangle, equals the total of 376 square feet. And now, we'll go about solving this. Just as we have in previous problems, we can start by subtracting 120 from each side. It's going to give us S squared is equal to 256. Next, we need to take the square root of either side, and we get that S is equal to plus or minus the square root of 256. Now feel free to do this with prime factorization or plug it into your calculator, whatever method you want. I happen to know that that is equal to 16. The square root of 256 comes down to 16, so our answer is the side length could be plus or minus 16. Now if we look at B, explain whether all solutions are viable. I'd say no, only the positive answer is viable because you cannot have a negative side length. Okay, now let's look at this second problem. Second problem says, in a science class, the students were asked to create a container to hold an egg. I think the physics class was doing this recently, I think I saw. They would drop the container from a window that is 25 feet above the ground. If the equation of the container's pathway can be modeled by the equation h equals negative 16 t squared plus 25, how long will it take the container to reach the ground? So here, h is its height, and t is time. Find the maximum height of the container. So if we think about this logistically, when will the egg be at its highest point? right? We're going to drop it. As soon as we drop it, is it going to get higher or lower? Hopefully you can see that it's going to fall, so that height is going to get lower as time gets bigger. And if we want to see how that shows up in our equation, well, if we think about t increasing, right, time passing, this t squared term is going to get bigger, and it's being multiplied by a negative. So that means height is going to decrease because this term, negative 16 times t squared, is going to get bigger, but more negative, right? So it's going to become more and more negative as time goes on. And therefore, the maximum height of the container will be right before we drop it, right? Once we drop it, it's only going to fall. So right before we drop it, that's at time 0, right? If we start time right when we drop it, then t equals 0 is right before it drops, and that's when it'll be at its maximum height. And so if t is equal to 0, then h is equal to negative 16t squared plus 25. H is equal to negative 16 0 squared plus 25. 0 squared is going to be 0. Anything times 0 is 0. So you just get h is equal to 25. The maximum height would be 25 feet. And hopefully you can see that from the problem too. They would drop this container from a window that is 25 feet above the ground, right? If they start 25 feet above the ground and drop it, it's never going to get higher than 25 feet off the ground. Okay, so now we need to figure out how many seconds will it take the container to reach the ground. Well, we have our equation. H is equal to negative 16t squared plus 25. When, what will the height be when the container reaches the ground? Well, if it starts 25 feet above the ground and we put 25 here, then the container will hit the ground when h is equal to 0, right? If it starts at 25 feet, it's going to fall at based on this term, and it'll hit the ground when h is 0. So we think about 0 is equal to negative 25t squared plus 25, right? Solving this for t will tell us the time when the container reaches the ground. So let's start by subtracting 25 from both sides, and negative 25 is equal to negative 16t squared. We want to divide by negative 16. We're going to get t squared is equal to positive 25 over 16. And now we want to take the square root of both sides, and we're going to get that t is equal to plus or minus the square root of 25 over 16. And this would be equal to plus or minus the square root of 25 over the square root of 16. Remembering we can break up our fractions like that. This is then equal to plus or minus 5 over 4. So my formal answer here is going to be t is equal to plus or minus 5/4. Now, only one of those two answers is valid. So I'm going to put in a little star, and I'm going to say only 5/4 is valid because time only moves forward. So t cannot be negative. If we start at t is equal to 0, it makes sense for time to get bigger. It doesn't make sense for time to become negative. Right? When time passes, time is only going to increase. So we're only going to look at the positive solution. So we're going to say 5/4 seconds or 1.25 seconds. Right? That's how long it's going to take the egg to reach the ground. Okay, now looking at this last one. A rock falls from a cliff 144 feet high. The function h of t is equal to negative 16t squared plus 44 models the height of the rocks as it falls, where h is the height in feet and t is the time in seconds. After how long will the rock land on the ground? Are all solutions of h of t viable? Explain your reasoning. So same thing as the last problem. When h of t is equal to 0, the rock will be on the ground. Therefore, we're looking for when 0 is equal to h of t, which is negative 16t squared plus 144, right? When this function is equal to 0, that's when the rock will be on the ground. You notice the rock is starting at 144 feet and is falling at this rate. So we can follow the same procedures we did on the last one. We'd get negative 144 is equal to negative 16t squared. We can divide both of these by negative 16, negative 16, and negative 16, 144 divided by negative 16, well, that's 9. So 9 is equal to t squared, which means t is equal to plus or minus 3. So we get that this function will be equal to 0 when t is plus or minus 3. So the rock will hit the ground 3 seconds after it is launched. And we want to note only the positive answer is valid. That's for the same reason it was up here, right? Time is only going to move forward. When we start at t is equal to 0, after 1 second, t will be 1, t will be 2, t will be 3, so we're only looking at positive time.